welcome back to a new video. So from this video onwards, we are starting with our new playlist, that is the LinkedList playlist, and this is the first video from the LinkedList playlist. So without further ado, let's get started. So the first question that we have here is middle of the linked list. So what does the problem state? So we'll be given a linked list and we have to return the middle node of the linked list. So here in this case, our linked list is containing 5 nodes. So we have to return middle of the linked list. So as you can see here, the node 3 is the middle, as there are 2 nodes to the left side of the node 3 and 2 nodes to the right side of the node 3. So you have to return entire node 3 as our answer. So you might say, in this case here the number of nodes are even and it is easier to find the middle node of the linked list, as there are 2 nodes to the left side of the node 3 and 2 nodes to the right side of the node 3. What if linked list is containing even nodes? So here in this case our linked list is containing 6 nodes which is even. So can I say my node 3 is middle here? No, I can't, because there are 2 nodes to the left side of the node 3 and 3 nodes to the right side of the node 3. So there are no equal nodes to the left and right side of the node 3. So can I say node 4 is the middle of the linked list? No, because there are 3 nodes to the left side of the node 4 and 2 nodes to the right side of the node 4. As the nodes to the left and the nodes to the right are not equal, so we cannot say here the 4 is the middle of the linked list. So in such case, the middle will be in between the node 3 and node 4, somewhere about here. So in that case, our 3 is the middle one and 4 is the middle 2. So when we are having linked list with the even number of nodes, so we have to return the middle 2 as our middle of the linked list, which is nothing but our answer. So let's try to solve this question. So the extreme brute force that is coming to my mind is something like, here we are having 5 nodes in our linked list and my middle node is node 3, and in the other example there are 6 nodes in our linked list and our middle node is number 4. So if somehow we can manage to get the relation between the number of nodes and the middle node, we can easily solve this question. So here our n, that is the number of nodes in the linked list, are 5 and the middle of the linked list is 3. So how can we get the middle of the linked list from total number of the nodes in the linked list? So I can use formula n by 2 plus 1 to get the middle of the linked list. So in this case, there are total 5 nodes in the linked list. So my n will be 5. So 5 by 2. So that will be integer division, plus 1 will be the middle node. So integer division of 5 by 2 will be 2, plus 1 will be giving me 3, which is nothing but my middle node of the linked list. And in the another case, we are having our n as 6. So the integer division of 6 with the 2. So n by 2 plus 1 will be 6 by 2 is nothing but 3, and 3 plus 1 is giving me 4, which is nothing but our middle of the linked list. So with this approach, I can easily find the middle of the linked list. So if I am having total number of nodes in the linked list, so it will be easy for me to find the middle of the linked list. So how can we find the total number of nodes in the linked list? So I can iterate over the linked list to find the total number of nodes. So I'll take a pointer temp which will be pointing to the head of the linked list, and I'll also take a variable count which will be initially equal to 0. So now we'll check if our temp is equal to null or not. So in this case, our temp is not equal to null, so we'll increment our count and our count will become 1. And now temp will move to the next node. So our temp is pointing at 2. So we'll check if temp is equal to null or not. So in this case it is not null, so we'll increment our count which will be equal to 2 and we'll move our temp to the next node. So as our temp is not equal to null, so we'll increment our count and we'll move our temp to the next node. So here our temp is pointing to node 4, so it is not equal to null, so we'll increment our count and we'll move temp to the next node. So here our temp is pointing to the last node, which is 5, and it is not equal to null, so we'll increment our count and we'll move temp to the next node. So here our temp is equal to null, so we'll stop iterating and we have got our total number of nodes in the linked list, which is nothing but 5. So with help of this total number of nodes, we can easily find middle of the linked list with the formula n by 2 plus 1. So this will be giving me my middle node. So here my middle node is equal to 3. So now I'll reinitialize my temp to head and I'll start iterating over our linked list again. Now, as our temp is pointing to node 1, so we'll decrement our middle node value. So it will be become 2 and we'll move our temp to next node. Now our temp is pointing to node 2. While moving ahead, we'll decrement our middle node value. So it will become 1 and we'll move our temp to the next node. So temp is pointing to node 3. Now we'll decrement our middle node value and it will become 0. As it has become 0, so our temp is pointing to the middle of the linked list. So now we'll break and we'll return our temp as our answer, which is nothing but the middle of the linked list. So that was the brute force approach to solve this question. If I have to code this, so how I can do this? So let's see the code for this. Firstly, we have to find the length of the linked list. So for that, we need to iterate over the linked list. So I'll initialize my temp pointer to head and we need to iterate till our temp is not equal to null. So while my temp pointer is not equal to null, so I'll keep on iterating. So while iterating, I'll increment my count. So for that, I need to take a count variable which will be initially equal to 0. So as we are iterating over our linked list, so we'll increment our count. So count plus plus and we'll move our temp to the next node. So temp equal to temp next. So at the end of the iteration, when our temp will be pointing to null, so our count will be holding the total number of nodes in the linked list. So as our count is containing the value of total number of nodes in the linked list, so we'll initialize the variable middle node with the total number of nodes in the linked list. And again, we'll initialize our temp to here and we'll start iterating over our linked list. So while true, we'll start iterating over linked list till our middle node value is not equal to 0. So we'll decrement the value of our middle node. So middle node minus minus. So that will decrement the value of the middle node and then we'll check if our middle node, if it is equal to 0, then we are pointing to our middle of the linked list. So we need not go ahead and we'll simply break out of our while loop. And if our middle node value, if it is not equal to 0, then we'll simply move our temp to the next node. So temp equals to temp next. So when our middle node value will be equal to 0, so we'll simply break out of the for loop and our temp will be pointing to the middle of the linked list. So we'll simply return our temp as our middle of the linked list. So that was it about this approach. So let's try to see the time complexity and space complexity for this. So as we are iterating over complete linked list to find the number of nodes in the linked list, so this for loop will be taking me the big O of n time complexity and then we are again traversing over the linked list till the middle node. So this for loop will be taking me big O of n by 2. So the overall time complexity will be nothing but big O of n plus big O of n by 2. So it is two-pass solution. And what about the space complexity? So as we are not using any extra space, so here my space complexity will be big O of 1. So that was the brute force approach to solve this question. So let's try to see the optimal approach to solve this question. So here our optimal approach will be based on the method of Tortoise and Hare. So here we'll be taking two pointers. The one pointer will be slow and the second pointer will be fast. So initially our slow and fast will be pointing to our head. So as we move ahead, our slow will be moving ahead with the one node at a time and our fast will be moving ahead with the two nodes at a time. So let's try to dry run this for this example. So now our slow and fast are pointing to head and we'll try to move slow and fast ahead simultaneously. So our slow will move ahead by one node and our fast will move ahead by two nodes. So slow will be pointing at node 2 and fast will be pointing at node 3. Now we'll again move our slow and fast simultaneously ahead. So our slow will be moving ahead by one node and our fast will be moving ahead by two nodes. So as soon as our fast points towards the last node, so you can see our slow is pointing at the middle of the linked list. So we'll stop iterating over here and we'll return our slow pointer as our answer as it is pointing to the middle of the linked list. So you may have the question, Here the length of the linked list was odd. So our first was pointing to the last node. So what if the length of the linked list was even? So let's try to dry run this for the linked list with the even length. So here our linked list is containing 6 nodes. So we'll initialize our slow and fast to the head of the linked list, and we'll start iterating over the linked list, and we'll move slow and fast simultaneously. So our slow will be moving ahead by one node and our fast will be moving ahead by two nodes. So our slow will be pointing at node 2 and fast will be pointing at node 3. Now we'll move our slow and fast simultaneously. So our slow will be pointing at node 3. So our fast will be moving ahead by two nodes. So it will be pointing at node 5. Now, as our fast is not pointing to the last node, so we'll move our slow and fast ahead. So now our slow will move ahead by one node and our fast will move ahead by two nodes. So our fast will pointing to the null. So at the end, when our fast is pointing to the null, our slow is pointing to the middle of the linked list. So in this case, when we are having the linked list with the even node, so when our fast will point to the null pointer, we'll stop iterating. At that time, our slow will be pointing to the middle of the linked list, and that will be giving us our answer. So in case of linked list with the odd number of nodes, so we need to stop when our fast is pointing to the last node. So that would be the fast next would be equal to null. And when we are having the linked list with the even number of nodes, so we'll stop iterating when our fast will be equal to null. So that was the tortoise and hare method to find the middle of the linked list. So let's see why this method works. So let's suppose you are having a vehicle 1 which is traveling at the speed of 50 km per hour, and vehicle 2 which is traveling at the speed of 100 km per hour. And let's suppose you are having the total distance of 600 kilometers. So let's suppose when our vehicle 2 has completely traveled over 600 kilometer distance, so what will be the position of our vehicle 1? So as you can see, our vehicle 2 is traveling at the double speed as that of vehicle 1. So the distance traveled by vehicle 1 will be the half as that of traveled by the vehicle 2. So our vehicle 1 will be at distance 300 km, which is nothing but half of the original distance. So that's why in the case of fast and slow pointer, when our fast pointer reaches the end of the linked list, our slow pointer is pointing to the middle of the linked list. So that's how this method of tortoise and hare works. So let's try to see pseudocode for this approach. So to start with, we'll require two pointers. So one will be slow, which will be initially pointing to head, and one will be fast, which also be initially pointing to head. So when we need to stop iterating over our linked list. So as we have seen, in case of linked list with odd number of nodes, when our fast will be at the last node, so we need to stop iterating our linked list, and at that point our slow will be pointing to the middle of the linked list. And in case of the linked list with the even number of nodes, when our fast will be pointing to the null, we'll stop iterating, and at that time our slow will be pointing to the middle of the linked list. So we need to iterate our linked list while our fast is not equal to null and our fast is not the last node. So fast dot next is not equals to null. So why we need to check both the conditions? So we might not know what is the length of the given degree. It might be even, it might be odd. So we need to take care of both the conditions while we are iterating over the linked list. So we'll move our slow by one node. So slow equal to slow next, and we'll move our fast by two nodes. So our fast will be equal to fast next. So this will be moving our slope by one node and fast by two nodes. So at the end of the iteration, when we break out of our while loop, our slope will be pointing to the middle of the linked list. So we'll simply return our slope as our answer, which is middle of the linked list. So that was the pseudocode for the tortoise and hare method. So let's try to analyze the time and space complexity for this approach. So as we are iterating over our linked list till the middle of the linked list, so our time complexity will be big of n by 2, where my n is the total number of nodes in the linked list. So what about the space complexity? So as we are not using any extra space, so in this case, our space complexity will be big of 1. So that was the pseudocode for the tortoise and hare method. So let's try to code this question. So to start off with, we'll require two pointers. So list node star slow, which will be pointing to head, and list node star fast, which will be pointing to head. Now we need to iterate over our linked list. So while our fast is not equals to null and our fast is not the last node. So fast dot next is not equals to null. We'll iterate over our linked list. So now we'll move our slow pointer by one node and move our fast pointer by two nodes. So slow equal to slow next and fast equal to fast next. Now, when we stop iterating over our linked list, our slow pointer will be pointing to the middle of the linked list. So we'll simply return our slow as the middle of the linked list. Now, let's try to run this on the sample test cases. So as you can see, it has successfully passed all the sample test cases. So let's now try submitting this. So it has successfully passed all the test cases, and indeed we have solved this question.